All right, so now I have the SST. I'm going to highlight that because I believe they don't ask you for that, but they ask you for the sum squared error. So here I started to type in the error. That's the error between my model and the actual. So actual minus predicted. If I scroll that down, B2 minus C2, this should be B3 minus C3. And then I look at that. This is my total error between actual and predicted. Now, I don't know if here they want predicted minus actual, or standard in science is actual minus predicted. So you might have, if you type in minus 147 into this place right here, and this is what they're asking for, is they're asking for the error. What is the error in your prediction? It might be the case that this should be 147. I don't know. So if minus 147 or the negative answer doesn't work, change the sign. And over here, they want the predicted height. So in this one, what is it after 9 seconds is 765 meters. For my case, it's going to change for you because your x values will change and your model will change. Here, they want it after 15 seconds. That's 1,185. That's what goes into this slot. And now we want the sum square error. So now I have the actual error. I like to look at both, so I make a separate column for that. And sum squared error is the error squared, because I'll show you in a minute, because I think the person who wrote this had a sense of humor. So E2, you see it highlights right away. I square that and I run it down. And my sum squared error is going to be the sum of these two guys. So that's sum of F2 colon F3. You don't have to put everything where I do, but that's the sum squared error of this model. I should be careful here. This is the error of my model, because they're about to, I'm going to put this, if you look at right here, this makes a word wrap, it wraps your text so that I can just keep going. SSE of my model. So I'm going to do this, click it, and do that so that I can see the header. All right, so now I have that information, and I've answered all the questions here. So I'm going to get rid of that. I'm going to go back to the word problem, and then I'm going to copy and paste this person's Lieutenant Dumb. And I'm going to put that into here so I can see what the problem is. And I'm going to shrink it down again because it's way too huge. So now they have another model. It's what we call a constant model. They're using 786. That actually is the average of these two guys. So it's what we call the null model. So you can tell when a statistician wrote this because they think of the null model as being a model. And sometimes the WebAssign problems have been written so that SST, or the null model, is not considered as a model. It's something about your data. It is about your data, but the average is a model. And so they ask what the error in Lieutenant Dumb's model in the first observation. What that is, let's go over here. Error Lieutenant Dumb. So the error would be the actual minus the predicted. So that's actual height was B2. Predicted height would be the average model. So I already have that. That's in B4. Oh, I feel like I've done this before. So that's minus 168. And notice I put the dollar symbol because I intend this to scroll this down. So that's the error between Lieutenant Dumb's model for each data point. Now notice if I just added the error here, I would get 0. This is why we don't just, this is why we square it, because the error is not 0. And so I don't want to just add that. So the sum square, SSE, I'm going to put Lieutenant Dumb, even though this is dumb, just to show you, I would square the error. So the process would be the same, but actually that's the same thing as my sum squared total. But that's what sum squared total does. And so the sum squared error is exactly the sum squared total, but I'm just, humor me. Notice I got the same thing. So that's the SSE of Lieutenant Dumb's model. Lieutenant Dumb is just using the null model.